So let's discuss from the first question here. So first question, I ask you to do a true or false question, okay, and then prove it whether it's true or false. So first question says the formula x1, x2 defined by the set of s1, comma set of s2 defines an ordered pair. So what's this question asking? A lot of you says that because in the lecture we define set of s1 and set of x1, s2. This is an ordered pair, and then so this is not an ordered pair. But remember that we say that after we define it, right, we prove a property about the ordered pairs. Do you still remember? So let's return, open the other nodes. And go back to the very beginning, we did ordered pairs. Yeah, here. Okay, can run C and see or not? Or a bit bigger a bit. Is it okay if we go side by side like this? Can see or cannot see? Very hard to see. One a bit. Side by side can see or not? Like this. Is it small? Too small? Too small? Small one. Okay, never mind. Okay, so yeah. You can also have your lecture notes on your hand, okay? You don't need to just keep looking at me because this is the lecture note I posted on Moodle. So I define order pair like this, but we remark that this property, right, is really what we want the ordered pairs to have. Okay, so what's this property here? If you need to define the ordered pair, you need to make sure that if x1 t1 equals s2 t2, the first, it has to equal on components wise. Okay, so meaning x1 has to equal s2, t1 equal to t2. And we remark here, okay, this property promises to make the definition of an ordered pair. So actually you can make different definition as long as you have this defining property here. Okay or not? So there's not just one way to define it. Okay, so if you say that, oh, I have to define this way, then I give you partial marks. I cannot give you full marks. Okay, I give you partial marks. Okay or not? Okay. Does it make sense? Understand what did I say just now? Understand? So to define an ordered pairs, you just need to make sure that if two ordered pairs is the same, it has to equal components wise. Okay? But the definition I gave in the exam, you cannot do that. Okay, because you cannot differentiate, for example, 1, 2, and 2, 1. You cannot differentiate 1, 2, and 2, 1. Is it clear why you cannot differentiate 1, 2, and 2, 1? Is it clear why you cannot differentiate 1, 2, and 2, 1? Okay, Brian, Why can't you differentiate 1, 2, and 2, 1 in question 1, 1? No, I mean, you see, I use this definition, right? Okay, I put 1, 2, and I put 2, 1. So what are 1, 2, and 2, 1 here? No, not x1, x2. Set containing 1 and set containing 2. See here, here. Look at here. Don't think anything else. Okay. How about 2, 1? Set containing 2 and a set containing 1. So are these two sets equal or different? Equal. So you cannot differentiate 1, 2, and 2. So this is not the kind of ordered pair we want. The ordered pair we want, we have to make sure if 1, 2 equals to 2, 1, 1 have to equal to 2. But clearly not. Okay. Does it make sense? Yeah. So first is false. So if you say that, oh, this definition is different from the lecture definition, I give you partial marks. I don't give you full marks. Yeah, I give you partial marks. You can earn partial marks. Let's see, I record here. I think I gave up to 2 marks or 1 marks. I forgot. Okay, at least 1 or 2 marks for explanation. If you say that this definition is different from the lecture. So for every true and false choices, I give you 2 marks. Explanation, 3 marks. Okay, so made up 5 marks each. 2. Let A and B be 2 sets, and then the power set of A union power set of B is equal to power set of A union B. So I think most of you done this quite well. Okay, actually one of the inclusion doesn't work. Which inclusion doesn't work? Huh? Left to right, right to left. This direction might not work. Okay, yeah, so you need to give an example why this direction doesn't work. Okay, so this one is false. Okay or not? Okay, so I mean, what example you can give? I think most of you done it quite well if you do it right. You could simply take A equals to maybe 1, 2, and B equals to 1, 3. Like that. So what is A union B in this case? 1, 2, 3. So 1, 2, 3 is one of the subset of A union B, right? But what? But how about on the other side? So okay, let's work it out. Let's work it out. So what is so let me put 2 here. So A equals to 1, 2, B equals to 1, 2, 1, 3. So what's the power set of A? Should be there are 2 to the 2 power of 2 things, right? So you have V 1, 2, and 1, 2. Okay, so similarly for B, you have V 1, 3, and 1, 3. Okay, but what's the thing that's in PA union B that's not in the union of these two? Ah, yeah, sure. You can take 2, 3, so not that. Set of 2, 3 is in P of A union B, but 2, 3 okay, in this one. It's not in PA union. Right. There's no set of 2, 3 inside here. Okay. Make sense or not? Does it make sense? Okay. Okay. How about question 3? So question 3 is true. Right. What did we learn in class? If Fg is injective, then G is injective. Okay, so you can do it inductively. Okay, I don't require you to write down the inductive step here. I mean, inductive proof, but you can just simply say by inductive. Okay, because this question is kind of short, so that's fine. And inductive is quite clear, I guess. Yeah. So that's not a big deal. Okay. So the problem is I want you to observe that if you have Fg is injective, imply G is injective, then you can apply to a string of composition of function. Because you can see, okay, some of you regard this as Fn composed up to F2 and then with F1. Okay, but how I think about this is Fn with Fn minus 1 up to F1. Okay, the outer one is injective and then the inner one is injective. The inner one is injective, then the inner one, the more inner one is injective. Does it make sense? So that's where the induction come from. But you guys first use associativity, associate the other way first. Correct or not? Because normally when we think about composition of function, right, it should be from, where is it? This one is right to left, correct or not? But you associate the last first, yeah, last few. But it's fine. Yeah. Because why there's a difference there? Actually, like for actually depends on what statement you want to prove. Actually, to be formal, I want to prove it for ON. But if you just fix an n, then obviously you can just associate like what you like. Okay, but yeah, I want to prove for ON. But that's fine. Yeah, that's fine. Okay. So the problem here is just show that if Fg, to use that, if Fg is injective, then G is injective. Okay. So this property is very useful in a frontier research. If you want to show a map is injective, I don't know how to show this map is injective, but maybe I can compose with something else. If after composition, that map is injective, meaning the first map you started with is injective. This is the usefulness of this proposition. Okay. At first, you don't know how to show injective, but after composition, it become injective map. Okay, good. The first one is injective. Okay, 4. Question 4, a bit confusing, but this statement here quite makes sense. You know, quite makes sense. If I replace this membership with subset, is it true or not? Is subset inclusion transitive? It's true. Why? A subset B, B subset C. What does it mean? Everything in A is in B. Everything in B is in C. So everything in A is in C. But here it's different. Here says that if X is in Y, Y is in Z, then X had to be in Z. True or false? False. And most of you actually give similar answer to mine. And you make similar choice. I think two of you give exact example as mine. So you can take one. One is in the set of one. The set of one is in the set of one. But it's one in the set of one. So one is in set of one, right? There's an element there. Set of one is an element in the set of set. But one is not in the set of one. Makes sense or not? One could be in set of one and comma one. Yeah. Okay or not? I think this is a very, how to say, very 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 obvious thing to think about when you first learn discrete math, right? Because in discrete math you learn what? Equivalence relation. You can try and think whether the property you have there is transitive or reflexive or what. Right? Yeah, so it's very natural things to think about actually. Okay, I can even give this question to a discrete math student. They should be able to figure out. Okay or not? Yeah. Yes, you was like, hmm. Yeah. I mean, what does no, this is an example only. This is an example. You can define other stuff, other example. But what does it mean by, let's say, okay, I give some more familiar notation to you. What does this mean? X in the set X. What does this mean? Oh, this means if I write X as a set, this set here contain X. That's all. This is the definition. S is a set containing S. That's all. 就这样罢了。哦。So I mean the quickest way to cook out an example is just quickly put a set bracket beside the element. This is the quickest way to cook out an example. Correct or not? Set. So if you are in something, so if you are an element of something else, that means that set contains you. Right. So if I want X is in Y, that means Y is a set that contains you. Okay, so Y is a set containing 1. Okay, and then Y is in Z, meaning Z is a set that contains you. So the question is, if I know that X is in Y, Y is in Z, should X be in Z? Not necessarily. I give you an example already. So the in you think about, actually you are thinking about subset inclusion. A lot of you draw this picture to me. X is in Y, Y is in Z, like that. This is subset, not element of. You are secretly using subset. Everything in the first ball is in the second ball. Everything in the second ball is in the third ball. This is a subset inclusion, actually. You didn't realize. So from here, I can catch you. You confuse. You confuse with elements and subset inclusion. You get what I mean? Okay, so this is what I meant. I want to know whether you really understand something. Okay, does it make sense? Make sense? Like this. Here, right, like this. So what is this equality here? Equal as what? Equal as set? Equal as element? They're different equal. Okay. So if equal as element, okay, let's consider 2. Okay. Equal as element. Okay. And equal as set. Okay. Are they equal as element or not? No. Why? This very much depends on how we define 1 and set of containing 1. So their definition is not equal. It's different thing. So we cannot compare as element. It's a bit dangerous to think like that. Maybe sometimes an element can be a set. So what you think about is by definition, they are not equal. Okay, your argument are dangerous. You know why? Because some set could be an element. You see. What's the element in this set here? What's the element in this set? Yeah, so it's a set, right? Set could be an element. Okay, so why they are different is just by definition. They are different thing. Okay or not? Maybe this one outside topic. Maybe in your different world, I define set of 1 to be 1. Also can. And in different world, I see set of 1 as 1. Can. It depends on how we define this guy. Okay, but the normal definition, we should separate set containing 1 and 1. Okay, in a normal world, they are different. That's all. In a special world, I can define set of 1 to be 1. Who knows? I can do it. But in a normal world, no, they are different. Okay, so second question is, are they equal as set? So equal as set means what? You have to start with both of them to be set first. So, okay, on the other side, I know it's a set that contains 1. But what is 1? 1 is a set or not? Can you think of 1 as a set or not? You can actually. Piano axiom can do that. Sorry? Subset of natural number, what do you mean? Huh? What do you mean by that? I don't understand. Still a set containing 1. You can do that, but that means you need to give your how to say, you need to give a model to your natural number. So there's a model on natural number using set theory, which is the piano axiom. I don't know you being introduced or not. So we can treat 0 as an empty set. We define, right? Define. And then 1 is set of empty set. We can do this. Okay, if I do this, what happened? If I do this, what happened? This one is set of empty set. Okay, now both of them is set already. So you can ask whether these two is the same or not. Why not? Sorry? This is the set of empty set. That one is empty set. Yes, this one is set of empty set. And then the other is set of empty set. But Leongen also can ask, so what? 名字不一样罢了嘛，对不对？很正常，其实你就讲对了，就是要 check 到底，做么他们不一样？为什么他们不一样？两个 set 怎么可能？什么时候不一样？左边的东西不在右边，或者右边的东西不在左边。说左边有什么东西 ？empty set 有东西，不要讲没有东西，有东西，这个东西是 empty set。
Goes back to
Yeah.
proving that empty set is not equal to the set of empty set.
Yeah. Sure.
So why is true? It's recursive.
Which one? What do you want to do?
If we don't take the empty set, we say that the empty set is in less than the set of the empty set is set of empty set.
Yeah.
We left with proof that empty set is not equal to set of empty set.
Sure. You can do that. You mean reduce to this case, is it?
Oh, yeah.
So this will imply this, is it? You mean?
Not recursive.
I mean, okay, here got what? Got one thing. On the right, left hand side, empty set. Here got empty set or not? No. Okay, no? Done, no? Actually, in this case, set or empty set also not in the left hand side. Yeah, they are not subset inclusion of each other. So I mean, you don't have any subset inclusion here. Okay. Okay or not? Okay. Yeah. I mean, this kind of exercise is easily can be done by a discrete math student. I mean, they can attempt it. I mean, they should try. I'm not saying that they can, but they should try. Question? Yes. Yes.
Is considered about X is a subset of Y is a subset of Z, then X is subset of Z, but that's wrong by definition. So
No, not wrong by definition. This is a different question.
Subset, not the
Do like what?
like,
What did you say?
subset.
You mean this this ball thingy Yes, this is a subset. You know why You cannot just listen, oh, I can do, then I do, or but you cannot explain why you do that. You know why? I mean, this is like a Venn diagram method, right? You know why Venn diagram looks like this? Why? What's the definition of subset? Let's say X is a subset of Z. What is that? What does that mean? Everything in X, it is in Z. So you see, everything in X, it is in Z. Inside Z. Contained inside Z. Because we use the ball to indicate that everything inside the ball is inside that set. So this is how the Venn diagram works. Okay or not? I mean, it's like, how to say, it's like this set notation. You just close the set notation like that. I think this makes more sense if you want to connect the definition. Okay or not? So Y is a set that contains one like this. Okay? Clear? Clear? Okay, good. Okay. Second, I don't know you notice one. Okay, maybe you haven't noticed. Okay, let's go through the answer and then you will notice that if you see the question is long, actually the answer is quite short. But when the question is short, the answer is actually quite long. Okay, later you will see this phenomenon. Okay, so let's see this question. So here are two equivalent formulations of axiom of choice. So first one is the obvious one that we discussed in class, epsilon choice of one. And then epsilon choice of two, we didn't discuss in class. But we introduced the definition of Cartesian product of infinitely many infinitely many sets. Okay. So I want to prove equivalence between these two. Okay, so it's good that if you copy the definition of Cartesian product into the exam, then you can use it. Okay, did you copy one? Okay. If you copy the definition down, really, there's nothing much to do. Why? Okay, let's see. So from 1 to 2, what do you need to have? So from 1, you are given a choice function already. For 2, what do you need to do? For Cartesian product. What's the definition of Cartesian product of infinite set? Or let us write down the definition then. So let's recall the definition. Definition. I think quite later lecture, right? Product topology. Correct or not? We'll introduce this. It's in lecture here. Okay. So how do you define Cartesian product here? So we define Cartesian product for infinitely set or any index, actually, any index, J, any index. So what's this Cartesian product here? What are the elements here? These elements are actually function. Function from where to where? Function to J, to the union of A alpha. What is J? J is the index set. Okay. So if your J is a finitely many object, so that means your Cartesian product is just product of finite set. Okay. But if it is infinite, then there are infinite things there. So I give you a number in J, and then you need to give me what? Give me an element inside this A alpha. Give me one. Okay, you see, X on one index, give me one element. Correct or not? Is this what Cartesian product do for you? For example, R2 lah. R2. What is the what does the Cartesian, what does the point 1, 2 do? Where is 1, 2? S equals to 1, y equals to 2. So the first coordinate, you split out a number in real number, which is 1. The second coordinate, you also split out a element in real number, which is 2. Okay, so it's a function. Yeah, no? Does it make sense? Okay. Okay. So here. So what do you have from axiom of choice? What do you have from axiom of choice? Anyone tell me? What do you have from axiom of choice? What do you have from axiom of choice? Liang Yuan.
Axis of function CE2. The B, it's just that the CB is an element of B for all the B.
Okay. Okay. Gary, how do you understand this sentence? You cannot read anymore, huh? How to understand this sentence? What is script B, first of all? What is script B? It's written there. What is script B? So the element there is non-empty set. So this function, if you fit one non-empty set, it gives you an element inside that set. Because it's non-empty, I can pick one element inside there. Okay. So if you have a Cartesian product of set A1 out to, I don't know, AJ, right? Okay. How do you build the element in the Cartesian product? How do you define? And how do you define? So your F have to going from where to where? Your F should go from the index set. So let's see what's the index set here. Maybe let's make it I to the union of A alpha, where alpha is in I. Okay. Okay. So if I give you an index I, what's the element I have to give you? Something inside AI. But how to choose something inside AI? Just use the choice function, because choice function says that if you give me a collection of empty set, I can pick one element for you. Let the choice function pick for you. Okay. So I write here Fi equals to CAI. Okay. Yeah. So the other way around is similar. If I can pick for every AI, for sure, I also can make the choice function. Okay, the other way around. So what is CAI? I just define it to be Fi, because Fi can pick it. Okay, because it's non-empty, you can pick at least one. Okay. Yeah. So I mean, we spent quite a long time doing this Excel of choice, so I think you'll be good if we put this inside a question. Otherwise, we will be wasting time in lecture. Because we spent quite a long time in this one. Yeah, at least 3 hours, I think, 2 to 3 hours. Oh, okay. So that's why I put this question. Usually, you won't see this kind of question in exam. Yeah, because to understand it, maybe it's already very hard. But since I already walked through with you, so I have to have some expectation, right? If you invest, right, do you expect something for return or not? I ask you. 会吗？如果你投资的话，要不要赚钱？会吗？是不是？所以我一定有一些 expectation 嘛。OK， 我不知道有没有赚钱吧，我一定想要拿回一些东西，可以明白吗？OK， yeah. So that's why I put this question in. So you can see that actually not much to do. What's the thing you need to do? You just need to define the function Cartesian elements of Cartesian product using choice function. That's all. Okay, nothing to prove here. Okay, if you do the right choice, then you get the answer right. Okay. 3A. How about 3A? 3A is about cardinality. It's about cardinality. So 3A and B are both cardinality. So A is about countable set, and then B is uncountable set. So what is A here? What is this set here? Set of all polynomials of degree n with fixed n already. Okay. And then what are these coefficients? These coefficients are integer coefficients. So you can put integer as the coefficients. So we want to prove that Pn is countable. So how should we do this? So every integer, right, is how many? How much? How many of them? That of them, right? Integers, many of them. But how many? How large is in the integer? Countable. Why? Sorry. So how to show that z is countable? What are you talking about? Definition. Oh, you can try and enumerate it, right? Last time we talked about in class. So how to enumerate it? Okay, Leung Yang say. Okay. Yes. 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 So you have to write that down because in class we didn't prove it. We only prove Z is equivalent to Q only. Sorry, N is equivalent to Q. Okay, so you need to write that down to show that Z is countable. Okay, but you see, how many Z here? NZ, fixed N. For fixed N, you have NZ. NZ meaning what? You have product of NZ. So we have learned already, right? Product of finite product of countable set is also countable. Okay, you can use that. No need to prove. Okay, yeah. Okay, so I think the one thing that require proof here is a Z equivalent to N. I think I never prove it in class. If got, then maybe I can give you point. For my memory, I think don't have. Okay, but we did prove N is equivalent to Q. But similar technique, similar technique. Okay, so this is where we testing you. Okay, and then how about the last one? Set of a binary sequence. I think this one quite similar to your assignment question, right? But in assignment question, you build an injection into binary sequence. But now I straight away ask you to prove binary sequence is uncountable. I think for those who do it, I think you know you are doing it right. You just use the same Cantor diagonalization theorem. Yes. Oh, yeah.
Fix zero and the first term in the binary form, and the after the dot, and the second after the dot, and every number is also is bijection from.
You mean biject to real number, is it?
Positive.
Yeah. You can, unless you show a bijection between real numbers. Yeah, you can do it.
Like the one from N to.
Similar to Z to R, you mean?
Just like 0, 2, and it is like 1.1 in
1.5.
1.1 in binary. 1.1. So it's like 1, 0, 1, 0, 0, 0, 0, 0, 0. It's a sequence of binary sequence, and we can convert back. It is.
No. I mean, okay. You are just saying that a set of binary sequence is bijection with real numbers, right? I mean, positive real numbers.
Yeah.
If you can show the equivalence, also can. Yeah, bijection. If not, you use the Cantor. So let's say you can enumerate, but you found someone that's not in the enumeration. Yeah, you also can directly show bijection, because this is how the number system works, right? How the binary numbers work. If you can make use of that, also can. You form a bijection straight away. Okay. Any question about this? Clear? Know how to solve it? A question? Okay. If not, maybe let's continue some more. 4A. Okay, so 4A trying to relate metric space and function together. Most of you got 4AA. Prove that isometry must be injective. Because if you start with a assumption that fx equals to fy, then the distance should be 0, because metric gives you that. But this question tells you that dfx dfy is equal to dxxy. So you also get that dxy is 0. But metrics tells you that if the distance is 0, then the 2 points should coincide. Okay, so give you the injectivity. B, is isometry necessarily surjective or not? Okay. Yes or no? No, it's not surjective. You can just try using translation. That's why I put the hint there, linear algebra. But I think most of you also get a even easier answer. You just include your space into a larger space. Yeah, you just include your original space. For example, R, you can include to R2, maybe x-axis. It's not subjective, but in both sides, you still keep your Euclidean metric, isometry, identity maps in particular. But you didn't reach other point, not onto. Also works. Okay. 3. Is there an isometry of 0, 1 onto 0? Okay, closed interval 0, 1 to open interval 0, 1. No. Okay, no. Why? Because in the first interval here, you have something that has length 1, which is 0 and 1, the distance between 0 and 1. But inside the closed interval 0, 1, if you're still using Euclidean metric, which 2 points will give you 1? None of them. Okay, because all the points are strictly less than 1 and greater than 0. So you cannot build a isometry as subjective. Okay, yeah, this one. This is question 4. Okay, a question 5, this one. This question, right? I want to demonstrate to you why it makes sense to define, for example, in matrix, we define a set is open, A equals to in A. Because if you in again, still you get in A. You get what I mean? So that's why it makes sense to define a set is open, A is equals to in A. Because if do in A again, still in A. So it's like the algorithm will stop somehow. You cannot forever in. Right? Yeah. Originally, I want to pair this question with, I want you to draw the in of an open ball. So if you have this result, right, what's the in of an open ball? Excel, correct. It's in of a closed ball is the open ball, but in of the open ball is the open ball. Actually, I wanted to put that question, but not enough room for me. So I replace with this one because I also want this. Why we define the open in basis element using the first line? Correct or not? We declare that U is open in the topology generated by basis element if for every point in the set you can find a basis element. Why it makes sense to do that? Because it has the following property here. You can actually write your open set using the union of basis element. Okay, makes sense or not? Okay, so that's why I named these 2 questions. One is open in metric, the other is open in topology. So when I said this question, I thought I want to use the law definition to do it, the interior definition. I mean, just proof by definition. But I know that some of you use that. You know that in A is open. So meaning what? If in A is open, really you just get in A equals to in A. Okay. But even if you notice that, I also give you mark. Okay, if you notice that, I also give you mark. Just that you skip through the definitions of in A because we already proved in A is open class. But I mean it's similar proof. Okay, for this one. So you need to show that for every point in A is in A, and every point in A is in A. Which direction is easier? Right to left, left to right. Why? If you have a point in A, what does it mean? There's a ball containing X is in A, but in A is in A. So the ball is already in A. Okay, so that point is open, is in A because there's a ball that contains the point which contained in A. The other direction is harder. Okay, the other direction you need to use triangle inequality. And you need to do the similar technique we did in class actually. And the other direction. So to see in A is in A. Suppose that X is in A. Then there exists R in greater than 0 such that BRX is in A. This one, everyone agree? Agree or not? Because S is in A. But what do you need to show? You need to show that this X is in A. What does it mean by this X is in A? Then it exists an open ball in A. So where do I find this open ball? There's a natural candidate there. There's a natural candidate here. Here. Okay, I'm trying to show that this ball actually is also in A. What I do. Okay. Okay. So I need to take for every point in BRX, show that it is in A. Okay. So I take any Y in this ball. Can I find another ball around Y such that it is in A? Can I do it or not? Can I find it or not? Can you imagine or not? So you got an X here, you got a ball here, BRX. Okay, and then you got an A here. Okay, what do? You take Y here. Okay, can you find a ball around Y such that this ball is in A? But I already know BRX is in A, right? So, and as long as I keep my ball inside BRX, then I am good. Because I know BRX is in A already. Okay. So what radius you need to choose? So the claim is I choose R minus dxy. So this is what we have been discussing inside the lectures examples. Okay. To show it, you just use the triangle inequality here. Okay. Why it works. Any problem, question? Okay. This technique we discussed in class before. Yeah, we discussed in class before. Remember, we draw some radius like this. Yeah. Okay, part B. You see, part B, the question is like 2 lines, right? Answer is also only two lines. Okay. So, one direction. Which direction? Yeah. Let's do one direction first. Let's say for every point U, you can find a B. Okay, such that B is contained in U. We want to show that U is the union of all these balls. How to show it? So some index set, right? So what kind of index set you can pick? Huh? Sorry. Sorry. Huh? So what index set? You can just pick every point in U and then take the ball that contains the point. So this is my claim. Is this true? Is this true or not? Left inclusion, why is it true? Because the point you pick, all the ball you pick contain all the point in U. Okay, it's the center of some ball. Right inclusion. Why? All the ball should be in U. Left and right both have. Okay. How about the other direction? Suppose you can write, so suppose you can write U as a union of some index set. Okay. Is it true that for every X in U, there is this some ball? Is it true? Because if X is in here, X has to be in the union. What does it mean by S to be in the union? Some BI. Okay, done. Okay, so this is the other direction. Okay, so if X is in U, then there exists some I in I such that X is in BI. So this is exactly the first sentence there. Okay. Got question? No. Okay. Okay, good. Next, 6. Okay, so this is kind of a question. So I give you a specific topology, and then ask you to show it is a topology, and then ask you whether this topology is Hausdorff or not. And then second, I ask you to find the closest topology on X that include this open set. Okay, so first question. I think most of you done it okay for topology. You know what to check. Okay, topology, what to check. Arbitrary union is open. And I said empty set, whole set is open. Yes, correct. I think most of you do it okay. Just that you mix up the assumption that the whole set could be a open set. Okay, the whole set actually is an open set, right? Oh, I mean, sometimes this open set a bit tricky. They how to say let me think. Okay, so let's go down here first. So I mean, when you take union, when you take intersection, right? Sometimes if your choice include the whole X, then maybe the union become easier, or maybe the intersection become easier. So you need to discuss about that. But I didn't take off too many points from there. I think only one. I'm not wrong. Okay. Yeah, there's a subtlety here. Okay, you need to discuss when you take arbitrary union or finite intersection. If the collection there have the whole set, what do you do? Yeah, and then what? And then the closest topology, I think most of you doing fine, but some of you just miss out maybe 1 or 2 subset. Okay, so you need to consider all the possible combination, finite intersection, and arbitrary union of the 3 things. Okay, yeah. 1, 3. Oh, I missed out here. Yes, I missed out here. When I marking also, I thought 1, 3 is extra, but I see so many 1, 3 here. I go and calculate again. Oh, got 1, 3 inside there. Yeah, I think it's a mistypo actually. I think it's a mistypo in my this solution. I think it's my problem, mistypo. Yeah, but okay. So if I accidentally take off your mark, you can claim for me because I got like deduct mark. Then I go back and check again. Actually, it's true. So you need to include 1, 3. Okay, yeah, you can compute. There are actually 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Should have 10 things there. Okay, should have 10 things inside your set. Our set? Too many. Power of X. You mean the power set of X, right? Too many things. Closest one. If power set is the finest one, because you contain all the subset already. You declare every subset to be open. But here only 10 of them is open. You know what causes means? Oh, find and cause is a contradiction. It's like greatest and smallest like that. Depend on how you understand 小 and 大. Yeah. Depend on how you understand 小 and 大. So final should contain more topology. Yeah. How's that?
Consider you need the least subset of it.
Yeah. Yes. So you need to catch the definition right. You see, normally people's problem is your idea actually not wrong, but you misunderstood what people want. This is most of the time. 懂什么意思吗？就是你要去理解人家要什么先。OK， 其实你的想法没有错的，你想法没有错，但是问题是那个不是人家要的东西。OK，so that's why 我们有这种问责的制度哦，就考试的制度哦，就是你能不能给出我要的东西 ？OK， 你给得出，我给你分，这样子，明白吗？考试不是玩玩的哦，不是玩玩的，就是真的要考验你们到底能做到怎样。OK， 明白吗 ？OK， 要对考试有一个正确的观念，才能够学到更多。OK，anyways， question 3。Question 3, so we have topology already, right? So next question is about basis for topology. So whether 1 and 2 is a basis or not. And then B, I think B is a bit tricky. Okay, B is a bit tricky. Why I said tricky? This is a bit different from the usual one, where I include singleton as open. The usual one only this one, A less than B. Correct, Euclidean topology. But now I include singleton. But this singleton is not every point, only at the integer. Only at integer. Okay, I don't add every point. If every point, then nothing to do. It's like a discrete topology. Okay, so 7a, you need to decide whether these two things are basis or not. So the first thing you met this kind of problem, yes or no, yes or no, yes or no. You think first. If you want to say yes, what do you need to do? Prove. Prove what to prove? Two property you need to prove. If you say no to that question, one counterexample. So which one you should do first? Which answer you should guess first? Counterexample first. See if you can construct a counterexample first. In exam, usually when we put question, the counterexample should be quite obvious one. So meaning easy to find. You simply throw in something, you should find it already. If you think, oh, try, still cannot, maybe it's true, then you can start and prove it. It's like that. Does it make sense? I think in real life also like that. When people discuss things with you, if it's not true, I don't need to discuss anymore. Give the counterexample. 不要再讲了，错的，没有东西要讨论的。有对的 ，OK， 我们可以 continue 继续讲。那错的一直讲下去也没有用。Understand or not? Okay. So don't waste time to prove first. First thing, correct or not? That thing. Okay. So which one is true? Which one is false? True and false. So first one is false. Second one is true. Okay. And then you guys want to discuss A or not? Or just skip it? I will pause this solution online as well. Just a tedious word for A. I think B is worth to discuss. Because why B worth to discuss? So let me list down the solution here. So in B is B, and then partial B is pi, and then b bar is 0 to pi. So what is b? B is 0 to pi. Okay. So if I were to write B using the topology in this case here, it is the open interval 0 to pi union with the singleton like this. Okay. So you want to ask about what is in B? What is in B? Definition in B. Definition in B. This one is topology, so you need to use topology in B. Okay, every point in B that has an open neighborhood that contain that point and in B. Okay, so see, I produce open neighborhood for all the points here. 0 also got open neighborhood. Everything between 0 and pi, 0 pi is the open neighborhood. It's already everything already. Okay. Boundary of B. How to check boundary of B? What's the definition of boundary of B? Every neighborhood at that point must contain point in B and outside B. So I think there are a few points you need to check. Everything less than 0, everything inside this set, and everything from pi to other things. Okay. So let's discuss one part first. Everything less than 0. If everything less than 0, can you find a neighborhood that avoid this interval? Can, right? Because it's 0 is 0 minus some epsilon if epsilon greater than 0. Okay, so you can pick epsilon over 2 size of open interval. 0, then this open set will avoid the complement. Okay, because at the boundary you need to show that every open neighborhood that contain that point contain points in B and outside B. But at 0, this one miss out the complement point. Okay. So similarly, in between 0 and pi, you can pick this open neighborhood here, 0 to pi. But at pi, some open neighborhood, not some or not every, need every boundary, need every. Okay, is it true or not? Every open neighborhood that contain pi, right, should be some open interval. I didn't declare pi to be open. No? I only declare integer to be open. Okay, so you have to include something pi plus epsilon, which is in the complement of the set. But anything other than pi, there's some distance with pi already. So you can squeeze your neighborhood. Okay, so you get what I say. So if you have 0 here, you have pi here, right? If you have some point greater than pi, then you can find the smaller neighborhood that avoid B. Does it make sense? Make sense or not? And if not make sense, please ask me. Okay. Please ask here. Okay. So boundary point is pi. How about closure? So closure is what? It's just interior union with boundary. Okay, so you just take the union of the two. So you get you take the closure of 0 to pi. But I think most of you got this B bar right. Maybe you are not thinking it right, but I still give you the point because I didn't ask you to give working for this question. Okay? Even if you guess correctly, I also give you. But after discussion, you must know why. Okay, you must know why. Okay? You must know why after discussion. Okay, so the mean for the exam is 49. Okay, and of course this result will be scaled. It will be scaled to mean maybe 72 to 74 like that. But I want to say there's people in dangerous zone, meaning like GJ, Gary a bit dangerous also. I count as 30 below is dangerous. Okay, because if you continue 30 in final, then it's quite dangerous. This is how I predict. Okay, so Pek Hong, Yan Ken, and Hao Ming. So to pass this course, right, you need to show improvement. Okay, both in assignment and final. Have to show improvement. Does that make sense? Okay, if you improve better than this result, surely you can pass. If you keep this performance, I think it's most probably very hard. Okay, it's hard. Does it make sense? Okay, now. So the game is like this. You must do your assignment really, really well. Don't make it like a testing. It's not a test. If I want to make it a test, I'll make it a quiz. Okay, then you cannot do research one. I test whether you know or don't know. But if I make it assignment, you have to go and find the right solution. Understand it, write it out. Okay or not? So that's why I give you times to do assignment. You know, this is the purpose. I give you one week or 2 weeks. Then within that period, you need to learn how to do it. Yeah. And you can ask me one. You can ask me. Okay. If you say, oh, I found some solution online. I don't understand this part. Okay, come and see me. You can ask me one. Okay. So my way is a bit different from the other lecturers. So don't assume their way. You can ask me one. Okay, ask me what can do, what can I do, what can I not do. Okay, we have different tastes. Okay, this is how we practice in Australia anyway. And if you go in there and study, this is how we practice also. Oh. Yeah. Okay, and I think actually we have 2 persons who get 90 and above. So first is Ding Yu and second is Ziqian. Ziqian 98, Ding Yu 90. Hey, what Yihan think about this exam? What do you think? Do you think hard or I don't know? Mixed feeling. Because you know why I know about you. You know why where I first learned about you? Actually, I don't know you, but you was in Darren class, right? Darren was really surprised. He said, "How you get 100? So how you get 100 in his class?" I also don't know. Okay. Okay. So I was like, yeah. I was like looking forward for your performance. Yeah. Maybe you should know. Just maybe, yeah, you should know. I guess you should know. Not too bad, not too bad actually. Your result. Good. Yeah, how about the rest then? What do you think? Very hard. Hard in any way or not? Ah, yes. Yes, that's right. That's right. You're going to over there. Oh, that's good. Oh, you are sick, right? You say you are sick last time.
After I watched, some kind I should think of that. Well, I'm not thinking that particular way,
Correct,
that
correct,
not
correct.
at that kind of mode.
Yes, yes, yes.
Turns out the result
Yes,
is
yes, yes, yes. So this counter example thing, right? I put in the first year when I teach them. First year they have to start thinking counter example already. Straight away deny the statement if you think that it's not true. No need to prove anymore. If you spend time, a lot of things you need to do. Yeah. Also, you need to have the ability to differentiate true or false. Okay. Yeah. So I mean the true false question also not very long one, supposedly. Yeah. It's false very fast. Should quickly short counter example. If true, I also won't put too long one. Yeah, unless the question paper too short. Yeah, depends. Okay. Yeah. Okay, and actually, when Chuan also not counted out this mark is just for your reference. Yeah, just for your reference. Yeah. So you know what thing you didn't learn enough, then you need to put extra effort on that direction. Okay. Something that you how to say miss, right? Something that you miss, then in the new topic, new subject, that part you need to take more care. Okay. Yeah. So this is how you learn. Okay, this is how you learn. Actually, it's fine one. It's fine. Learning you have to fail down. This is like cycling, cycling. You need to fall down a few times, then you can cycle. Sorry, you keep falling down. I already fell down for like 8 years. Really, I also fell down. You mean really down? I was after my PhD, right? I really don't want to do research anymore. I seriously don't want. You know why? I keep calculating, right? I can't see what's going on. The thing is like very huge. Yeah, this thing still got answer, or and answer is like few line. Mine is don't have answer one. Hmm? 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 No one in the world know. Even my supervisor also don't. Yeah. Preparation thinking. Otherwise you think I'm stupid one like here, like clone like that. I give this exam paper also like clone. Oh, I prepare your assignment, your exam. I spend a lot of time choosing the question. So if you think that, oh, this is just rubbish, very hard, it's okay. It's okay. I think this is your choice. Actually, maybe it's my mistake to come here. Seriously. If no one appreciate, okay, student don't appreciate, colleague also think like you are alien, then it's my fault lah, because I come here. No, you think correct or not? So my only hope is the student. If the student don't appreciate, no need lah, because I can do my own maths. The colleague here also like not really doing my field also. For most of them, I'll say. Maybe some of them do lah, clash a bit. Okay, maybe the closest one is the Christopher. Closest one is Christopher. And maybe next one maybe is Jiajing. Then others, not quite. No intersection. Yeah. So I mean, yeah, hopefully you can understand me. I'm trying to understand you, but hopefully you can understand me. Okay. Otherwise, I'm really a lone ranger here. 知道什么叫 lone ranger 吗？不知道，不知道啊，lone ranger。Yes， 我只是在单打独斗吧。很好笑，真的很好笑。但是你想的时候真的是很悲催的时候。这样我应该要努力一点做 research 当初。OK 啦，这玩笑话。哦，But 我只有一个心愿吧，就是你要持续的学就对了，你不要说哎呀难啊什么这样啊，我就不要随便乱读哦。我也是这样走过来的，我也是看这些题目不会啊，但是我现在会了啊，怎么你不要问我嘞？ 对不对？我也没有讲我不要教你啊，对吗？你花时间，我也愿意花时间的。好，只要你不放弃你自己，我不会放弃你的。easy，我很简单，我这个人很直接。我只有一个心愿吧，就把东西越做越好。如果有人要摆烂啊，那个我没有办法，那个是他的目标，我目标不是摆烂。OK，明白我讲什么吗？明白哈？OK，所以我不会乱 fail 人的，你不用怕，你只要进步，我不会 fail 你。好，我最怕的那种没有交 assignment 怎么办？我不能给你分，你没有交 assignment，我怎样给你分？你 assignment 你 test 没有写答案，或者你乱写，我怎样给你分？我就算一个给1分哦，也凑不到30分，你明白吗？You need to at least write down something that makes sense，对吗？你才可以证明你学了东西。我这个人很简单的，你只要学一点东西可以的，可以 pass。但是呢，考得好另外一回事，这是另外一回事。考得好，考得好什么情况？可能你有天分哦。我来这间学校的时候有天分，有学生他在班上不用听我讲课的，他在那边弄他电脑东西，看看一下，看看一下。我的 quiz 他考100分，我的 quiz 不是乱出的哦，我 quiz 我自己出的。什么意思呢？意思说他理解了那个 concept。如果你不是这种人，努力一点哦，我们都努力一点。我也不是那种人，我也是努力过来的，我也是整本书做 exercise，不止老师给我的 tutorial，所以我才 post 了很多 reference 在 Moodle 上面呢，对不对？我还找答案给你 ，solution menu 有做吗？我不是要骂你啊，我只是建议你啊去做，OK，不会去做，不要一直读没有用的。因为你没有去用那个 definition，那个 definition 对你是没有感觉的，你对 definition 也没有感觉，他不认识你，你也不认识他，因为不是我们日常生活的东西嘛，对吗？所以你要把它变成你日常生活的一部分，才会了解它，OK 吗？Knowledge is not cheap，记住这句话，天下没有便宜的知识，They don't come cheap，OK，没有便宜的知识，好，可以吗？可以明白我讲什么？OK 啊，Yeah，so，所以我们继续努力，好，我们继续努力，希望能够学出什么东西来，对大家都有用，make sense？make sense 啊？过去就过去了，is OK，未来继续努力，还有时间，还有空间，可以的。哎，我朋友啊，哎，我朋友不了，我学生，哦，他从 midterm 啊 fail 到 final 考几分？你猜？98，你不吓到我都吓到，真的。实际的例子，在我班是可以爬上来的，只要你肯努力，只要你听我讲，应该要做的，要怎么去做？你可以用你的方法，不用紧，it's okay，that's fine。但是你是可以做到的，我想这样说，OK？你不是一辈子就是那种人吧？我们是要爬上来的人，不要一辈子做井底之蛙。所以你看，你来学校啊，所以你父母送你来学校啊，他不想你再做他们那样的人，他想你更好，对吗？是不是这个意思？是不是这个意思？啊，好，他觉得他已经不能再做什么了，他希望他孩子可以做些什么。 啊呀，很多东西要思考的啊呀，你可以玩，你可以肯定跟你男朋友、女朋友，OK，这边只有女朋友啦，这边全部男的，可以的，你可以去消遣什么，但是你要安排时间出来读书，OK，你不要跟我讲啊，我有学生啊没有读哦，他跟我讲你的东西很难，你都没有读，在家又不读，他有一盒知识看 cheap 哦，一讲你就要会哦，你是谁？你一讲都会，你不去 MIT 不去哈佛，你来下蛋，对吗？我们来这里努力一点哦，是不是这样讲？我很讨厌的，很讨厌是学生不努力，然后又在那边靠北靠北。什么叫靠北靠北啊？知道啊？你福建人没？哦，你福建人呀，就在那边 complain 啊，这个难啊，那个老师又教不好啊。我问你，你读了多久？没有读，讲什么？很辛苦啊，你们自己来做老师，现在你们就知道了。换位思考，我以前做过学生，我知道学生的 pattern，而且啊，我是坐在他们的自习时间跟他们一起读书的，我是生，我是下去下场看，下场陪的，其他老师可能只是在班上跟你这样讲来讲去，讲来讲去。哦哦，我不是要批评你什么啊，我是要建议你，你可以走更好的路，你不要听不用紧，OK，但是不要干预我啊。如果你也能够走一条很好的路，祝福你，然后我们互相 agree。好，懂我讲梦嘛？明白啊，明白我讲梦呀。我没有要人不好啦，提前讲，OK，我们要一起 pass 啊，一起 pass。嗯，但是可能真的来说啦，真的来说，可能我水准是有点高啊，这是真的。OK，但是我为什么放这样高？我前面是不是跟你讲了，Brian，我讲了什么？还有嘞，更实际的问题嘞，什么？飞鸿你讲吗？还有嘞，啊，skill 什么啊？
做了被拉低了。对，你不是问我们要 skill 啊，skill 到那个啥？
哦，OK OK，那个是只是 side 罢了，还有一个更实际的问题，还有更实际的，还有更实际的，这些都有，但是还有一个更实际的，very practical 的，很 practical 吗？厦大的人 practical 吗？我就来讲 practical。Yes，你能不能上 master 生存？你能不能上 PhD 生存？这些老师很天真，你知道吗？他以为把你送出去啊，你就来自己打算了了。我读了这些啊，我在 PhD 都还在 suffer，你可以想象，这点东西算什么？我现在要讲，你明白吗？明白吗？所以我们要为了要去更好的大学，更好的装备自己，明白吗？OK，说装备自己的时候，就是你们刚才讲的那些咯，对 definition 的理解，对 logic 的理解，各种理解，这些 up 了，then 你上去 PhD，你就可以跟你的 supervisor 讨论了咯。啊，这个题目感觉好像不对嘞，我有 counter example 啊，或者说哦，我懂怎样 prove 啊，是不是？是不是这个意思？我问你，对吗？就是我们刚才在讨论的东西吗？对不对？嗯，对不对？OK，明白？OK 啊， 要知道哦，这个是有答案哦。PhD 没有答案，就这样。OK，还有问题吗？今天没有教到课啊。Motivation talk，yeah。所以希望大家有一点改变。我们 next semester 就是来这个 semester 的 last half，努力一下，过去你就是不一样的人，我保证，我保证，我只保证这个吧。这个应该很好了诶，好吗？你觉得？这个好吗？我觉得蛮好啊，吧？OK，so see you tomorrow。paper 帮我还回来一下，你们帮我算一下嘛？谁可以帮我算一下 paper？你帮我算一下。啊，你帮我算，可以，不要 mix with 这些。燕科 you can take a photo of your exam view 来，算一下这边有几个人啊？呀，算一下。你的还是给回来比较好，我怕等下这个题目乱飞。
等一下
OK，
如果要给你的波就有一个问题。
yes。哦，对，差点忘记了。等一下，我关他东西先。
哦，
呀，等一下我看。你的在这里。哎，你们的去系也可以带回去啊，如果。没有时间用嘛。OK，会不会想太久啊？
我就怕这个写，然后
啊，是，我看到你有空做不完啊。哦，有没有花太长时间想一题？有哪一题？
忘记了，还是让我重新。
哎，给我说一下。OK，make sense。OK。OK，等一下啊。
还有3个，看看。